Good morning, students. Today we are going to see the another two subtopic of Unit 5, integration of data analytics with the process monitoring and control system. The second one is future trends and emerging applications of data analytics in chemical engineering. Integration of data analytics with the process monitoring and control system is very important. The integration of data analytics with the control as well as it will help you to do the process monitoring. Okay, so data analytics with the process monitoring and control system, which we are going to see now. The definition goes like this: integration of data analytics with the process monitoring and control refers to the use of advanced data analysis techniques to enhance the performance, reliability, and efficiency of any industrial process systems. So it refers to use of advanced data analytic techniques to enhance the performance, reliability, and efficiency of the industrial process system. So the motivation of integrating the data analytics with process monitoring is due to increasing complexity of industrial system and the need for the real-time insights and the shift towards industry 4.0 and smart manufacturing. So the motivation, the reason for integrating the data analytics with the process monitoring is due to these three factors. Coming to the industry 4.0, so people have been talking about what is industry 4.0, and they may ask also, okay, industrialization. So starting with the industry 1.0, 2.0, 3.0, three global global stands, I mean in globalization, that is industry 3.5, and now we are, people have been talking for industry 4.0 in the developing nation, and in advanced nation like middle I mean US and western countries, they are talking about industry 5.0. Okay. Excuse me. So let me tell you actually what is industry 4.0 is a fourth industrial revolution. They are also called as 4IR or industry 4.0, is a neologism describing rapid technological advancement in the 21st century. It follows the third industrial revolution, that is called information age. The term was popularized in 2016, okay, by Klaus Schwab, the World Economic Forum founder and former effective chairman. A part of this phase of industrial changes is joining of technologies like artificial intelligence, gene editing to advanced robotics that blur the lines between the physical, digital and biological world. Throughout this, fundamental shifts are taking place in how the global production and supply network operates through ongoing automation of traditional manufacturing and industrial practices. Using modern smart technology, large scale machine to machine communication, that is called M2M, and Internet of Things, this integration results in increasing automation, improving communication and self-monitoring, and the use of smart machines that can analyze and diagnose the issues without the need for the human intervention. So it also represents a social, political and economic shift from the digital age of the late 1990s and early 2000 to an era of embedded connectivity distinguished by the ubiquity of technology in society that changes the ways humans experience and know the world around them. So the trends, when you see the smart factories, the fourth industrial revolution fosters smart factories, which are production environment where facilities and logistics systems are organized with minimal human intervention. Underline the word industry 4.0, organized with the minimal human intervention. The technical foundation on which the smart factories are based on cyber physical systems that communicate with each other using Internet of Things. The important part of this process is the exchange of data between the product and the production line. So the important part of the industry 4.0 is the exchange of data between the product and the production line. This enables more efficient supply chain connectivity, better organization within a production environment. Within modular structure, smart factories, cyber physical systems monitor physical processes, create a virtual copy of the physical world and make decentralized decisions. Over the Internet of Things, cyber physical systems communicate and cooperate with each other and with humans in synchronic time, both internally and across organization service. offered and used by the participants of the value chain. So this industry 4.0 nowadays the people have been talking which will make us to integration of data analytics with the process monitoring and control. So, okay, that refers to the use of advanced data analytic techniques to enhance the performance, reliability and efficiency of industrial process system. So the overview of process monitoring and control system: traditional process control, open loop, okay, closed loop control, PID control, the SCADA and DCS system, distributed control system. So you know already what do you mean by SCADA system, which we have seen in the previously, right? The SCADA is nothing but supervisory control and data analytics. Okay, so when we talk about this, you know actually what is the traditional process control. Okay, data acquisition. Okay, data acquisition, supervisory control and data acquisition. Coming to the process monitoring, use of sensors and data acquisition, KPIs, key performance indicators and process variables, alarm and event management. So the process monitoring is these three types: use of sensors and data acquisition. Okay, traditional is SCADA, supervisory control and data acquisition. Okay, and KPIs, key performance indicators and process variables, alarm and event management. What is data analytics? So there are this analytics has been classified into four types: descriptive analytics, diagnostic analysis, predictive analysis and prescriptive analysis. We will see one by one. What is a descriptive analysis? Descriptive data analytics focuses on summarizing and understanding the main features of a dataset, such as patterns, trends, and key characteristics. It involves using statistical techniques and data visualization to explore historical data and highlight what has happened in the past. Okay, so that is called descriptive data analytics. Okay, it involves using statistical techniques and data visualization to explore historical data and highlight what has been happened in the past. This type of analysis provides a foundation for further investigation and decision making. The key aspects of descriptive analysis, data analytics, focused on past data. Okay, it analyzes historical data to understand what has happened, identifying the trends, patterns, and relationships. Coming to the summary and description, the goal is to provide a clear and concise summary of data's key features. Statistical techniques: it utilizes various statistical methods such as calculating measures of central tendency, mean, median, mode, and dispersion, range, variance, and standard deviation. Coming to the data visualization, descriptive analysis often uses graphs, charts, and tables to represent and visualize the data, making it easier to interpret and understand. Foundation for further analysis: the results of descriptive analysis can serve as a basis for further investigation and decision making. Types of descriptive analysis. Okay, the measures of general tendency. This describes the average or typical value of data set, including mean, median, and mode. Measures of dispersion. This describes the spread or variability of the data, such as range, variance, and standard deviation. Data distribution. Descriptive analysis can be used to examine the shape of the data distribution, including its skewness and kurtosis. Data visualization. Various types of charts and graphs can be used to represent data, such as histograms, bar chart, pie chart, scatter plot, and box plot. Example of descriptive analytics in business: sales performance, analyzing historical sales data to identify the trends, seasonal variation on top selling products. Even in customer demographics, analyzing the customer data to understand the customer segment and tailor marketing strategy. So this is the descriptive data analytics for focuses on summarizing and understanding the main features of the data set. Coming to the diagnostic analytics. So coming to the diagnostic data analytics focuses on understanding the why behind past event or outcome by examining the data to identify the root cause and pattern. So the diagnostic analysis helps to examine the data to identify the root cause and patterns. It goes beyond simply summarizing what happened like descriptive analysis or predicting what might happen in the predictive analytics. Diagnostic analysis uses techniques like data mining, drill down analysis, and correlation analysis to uncover underlying factors. The key aspects of diagnostic data analytics focuses on root causes. It aims to understand the fundamental reasons for observed patterns or events. Retrospective analysis, it analyzes historical data to explain the past occurrences. Diverse techniques, it employs various methods like data mining, data discovery, and drilling down to uncover insights. Complementary to other analytics, it builds upon descriptive analysis and often serves as a bridge to predictive and prescriptive analysis. Example of diagnostic analytics application: healthcare, understanding the root cause of a sudden increase in hospital admission or patient symptoms, identifying the reason for declining sales such as poor customer reviews or competitor price changes. In the benefits of diagnostic analytics: improve decision making, understanding the root causes allow organization to make more informed decision. Process improvement, identifying and addressing the underlying issues can lead to significant improvement in efficiency and performance. So the diagnostic data analytics focus on underlying the why behind past events or outcomes by examining the data to identify the root cause and patterns. So to identify the root cause and patterns, the diagnostic analysis comes into picture. And coming to the predictive analytics, the predictive analysis or predictive AI encompasses a variety of statistical techniques from data mining, predictive modeling, and machine learning that analyze current and historical facts to make the prediction about future or otherwise unknown events. In business, predictive models exploit patterns found in historical and transactional data to identify the risk and opportunities. Models capture relationship among many factors to allow assessment of risk or potentials associated with a particular set of conditions, guiding decision making for candidate transaction. The defining functional effect of these technical approaches is that predictive analytics provides a predictive score probability for each individual in order to determine, inform or influence of organizational process that pertain across large number of individuals, such as in marketing, credit risk assessment, fraud detection, manufacturing, healthcare, and government operation, including law enforcement. So the predictive analysis encompasses a variety of statistical techniques from data mining, predictive modeling, and machine learning that analyze current and historical facts to make the prediction about future or otherwise unknown events. Okay, so that is called predictive analytics. So coming to the prescriptive analytics, prescriptive analysis. So what do you mean by prescriptive analysis? Any idea about, could you able to guess actually what would be the prescriptive analytics mean? The prescriptive analytics uses data and algorithm to recommend the best course of action for a specific situation. So uses a data and algorithm, prescriptive analysis uses the data and algorithm to recommend the best course of action for a specific situation, going beyond simply predicting the outcomes. Okay, it aims to answer what should we do by analyzing the data, considering the various factors, and providing the actionable insights for decision making. Okay, the action, underline the word actionable insight for decision making. So the key concepts are action oriented, data driven, optimization beyond prediction. So action oriented prescriptive analysis focuses on what action to take to achieve the desired results or optimize the outcomes, process outcomes. Data driven, it leverages data from various sources, okay, to inform the decision making. Coming to the optimization, prescriptive analytics aims to identify the most effective strategies or solution to maximize the efficiency or minimize the cost. Beyond prediction, While it builds upon predictive analysis, it goes further by recommending the specific action to influence the outcome. How it works? So, data collection and analysis. Prescriptive analytics gathers data from different sources and analyzes it to identify the pattern and trends. Model development, it uses machine learning algorithm, optimization techniques and other tools to build models that can simulate various scenarios and predict outcomes. Scenario analysis, these models analyze different decision options and their potential impact, allowing for a comparison of their effectiveness. Action recommendation, based on the analysis, prescriptive analysis provides recommendation for the optimal course of action to achieve desired results. The examples: optimizing logistics, preventing customer churn, principal strategies. The benefits of this: improved decision making, increased efficiency. So, improved decision making, prescriptive analysis provides data driven recommendation leading to more informed and effective decision. Increased efficiency by optimizing processes and strategies. Prescriptive analytics can help businesses achieve greater efficiency and reduce cost. Enhanced performance, prescriptive analysis can help organization identify the opportunities for improvement and taking proactive steps to enhance the performance. So, what is the advantage of these different types of data analytics? One is descriptive analysis, diagnostic, predictive, and prescriptive analysis. The advantages just now I told. So, coming to the techniques. So, what are the techniques which are available in data analytics? Statistical methods that we have seen in the last class. Okay, machine learning and artificial intelligence. So, why integrate with the control system? Predict the equipment failure before it happens. So, once the data we collected, obviously we know actually what is the action supposed to be taken, whether the data is going out of the range. Okay, if it is a skew data or anomaly, so detection of anomaly, so integrate with the control system that will help you to recover back to the correct position. So, integrate with the control system. Why? Predict the equipment failure before it happens. Detect the anomaly, find the anomalies and drift in real time. That means shift back to the real time. Optimize the process efficiency and quality. Enable the predictive and adaptive control strategies. Coming to the data collection, the sources, sensors, PLCs, historical database and MES. The challenges are noise, missing data and data volume. Now, what do you mean by PLC? Any idea? What do you mean by PLC? Can you guess? So here the programmable logic controller, the PLC is programmable logic controller or programmable controller is an industrial computer that has been ruggedized and adapted for the control of manufacturing processes such as assembly lines, machines, robotic devices or any activity that requires high reliability, ease of programming and process fault diagnosis. PLCs can range from small modular devices with tens of inputs and outputs in a housing internal with the processor to large rack mounted modular devices with thousands of input and output and which are often networked or to other PLC and SCADA systems. Okay, so they can be designed for many arrangements of digital and analog I/O, extended temperature ranges, immunity to electrical noise and resistant to vibration and impact. So the programmable logic controller is an industrial computer that is an ruggedized and adapted for the control of manufacturing process such as assembly lines, machines, robotic devices or any activity that requires high reliability, ease of programming and process fault diagnosis. Okay, so that is the source, the sensors as well as the programmable logic controller. Coming to the MES. So, what do you mean by MES in the data collection? So, MES is nothing but manufacturing executive system data collection involves gathering real-time information from the factory floor to monitor and control manufacturing operation. This data is crucial for decision makers, helping them optimize the production process, improve efficiency and maintain quality. So manufacturing execution system data collection involves gathering real-time information from the factory floor to monitor and control the manufacturing operation. So here more detailed for manufacturing execution system, data collection entitles data sources, okay, machines and equipment. MES systems collect data from various devices, including machines, sensor, and other equipment, providing insight into their status, performance, and usage. So, manufacturing execution system. The operators, MES can also collect data from operators, including their work performance, adherence to procedures, and any issues thereby they encounter. Other systems, MES integrates with other information systems such as ERP system, PLM, product lifecycle management system, and quality management system to get a comprehensive view of the manufacturing process. The types of data collected is production data, machine data, inventory data, quality data, everything it will collect. So this includes production rates, cycles, that is a production data, includes production rate, cycle times, output quantities, and any deviation from the expected results. Coming to the machine data, MES tracks machine status. Okay, so MES tracks the machine status as well. Manufacturing execution system tracks the manufacturing execution system tracks the machine status, performance, downtime, and any alert or notification related to machine health. So the inventory data, this includes information on raw materials, work in progress, okay, WIP, and finished goods, helping to manage material flow and optimize the production. So the quality data, MES collects data related to quality control, including inspections, measurements, and any defects or issues identified during the production process. Workforce data, this includes information on employee schedules, qualification, authorization, helping to manage workforce resources effectively. Process data, most of the time the process data, the MES, manufacturing executive system. Okay, manufacturing execution system in the process data track the process of production orders from launch to completion, helping to identify the bottlenecks and improve the overall efficiency. Okay, purpose of data collection. What is the purpose of this data collection? Production optimization, traceability and accountability, quality control, decision making, predictive maintenance. These are the reason for collecting the data collection. The sources, here they have given sensors, programmable logic controller, historical database, manufacturing execution system. Okay, in the manufacturing execution system data collection, so it provides a product optimization, provides insights into the current state of factory floor, allowing decision makers to optimize the production process, reduce the waste, and improve the efficiency. Traceability and accountability, MES tracks and documents each step of the production process, ensuring full traceability and accountability. Coming to the quality control, MPS helps to identify and address the quality issues, ensuring that products meet the required standards. Decision making, the data collected by MES provides insights into the current state of the factory floor, enabling informed decision making and strategic planning. Predictive maintenance, MES can collect machine data to identify the potential maintenance needs, allowing for proactive maintenance and reducing downtime. So the data collection sources is sensors, programmable logic controller, manufacturing, execution system. Okay, and challenges are noise, missing data, data volume. Coming to the integration of framework, data pre-processing. So the data pre-processing like anomalies, anything, refined noise level that can be clean. Okay, the cleaning, filtering, normalization. Okay, feature extraction and dimensionality reduction. So how to deal with the data pre-processing. Okay, dimensionality reduction and the feature extraction will help you can be carried out in the data pre-processing. Model building, time series models, okay, classification, clustering, regression, these are all different types of models which we have seen. Okay, coming to the tools, principal component analysis, artificial neural network, SVM, support vector machine, random forest, these are all what you call them. So unsupervised learning and artificial neural network is supervised learning, principal component analysis, reduction in dimensionality reduction, random forest, support vector machine, all supervised learning. So decision making and control. So integration insights into SCADA, supervisory control and data acquisition, DCS, digital control, distributed control system, Okay, DCS system, closed loop feedback using predictive models, human in the loop considerations. Now coming to the case study, where we'll adapt all this chemical reactor optimization example. So using regression models for yield prediction, real-time adjustment of feed rate and temperature. Okay, the second example is fault detection in the heat exchangers, PCA based anomaly detection, alert integrated with maintenance scheduling. Okay, so these are the case studies regarding the what you called integration of data analytics with process monitoring and control system. Okay, coming to the next part, that is a case study. The third is predictive maintenance in pharma manufacturing, machine learning models using vibration and temperature data, triggering the condition based maintenance action. So benefits of integration. Why we need to integrate this data analytics with the process control and monitoring. So increased uptime and reliability, better product quality and consistency, reduced operational cost and energy usage, enhanced decision making and capabilities. Okay, coming to the challenges and consideration in integrating the data analytics with the process control and monitoring, data quality and sensor reliability, integration with the legacy systems, cyber security and data privacy, skill gaps and organizational readiness. The tools and platforms which have been used in the open source as well as in the industrial platform, OSI software PI system, Honeywell PhD, GE Predicts, in a open system source and commercial analytics like Python, R programming, MATLAB, TensorFlow, Azure IoT, AWS, Greengrass. Okay, so the R programming is again Scilab, what do you call it, similar to Scilab, what do you call yeah, you could learn the R programming in IIT Bombay tutorial. There is a one link is there. Just go and type IIT Bombay tutorial where the language has been R programming like Python. You can learn also. Python you can do it in a Jupyter notebook, right? So these are the things. So MATLAB, we have a version, MATLAB version actually in open source at HPC that also can be used. Okay, for the things. So what the first part of the fifth unit, that is the third subdivision, integration of a data analytics with the process monitoring and control system. So integration of data analytics with the process monitoring and control. So whenever the data has been obtained, okay, with the proper process monitoring as well as it to control. So if there is any deviation, that can be recovered back and come to the real time. So that's what they say. The direct anomalies and drift in real time. Okay. So these are the examples which has been told. Data analytics integration with the process monitoring and control. One is chemical reactor optimization. So using regression model, you can find the yield prediction. Real-time adjustment of feed rate and temperature can be carried out. Fault detection in heat stages, PCA based anomaly detection can be carried out, and then alert integrated with the maintenance scheduling. Coming to the predictive maintenance in pharma manufacturing, machine learning models using vibration and temperature data, triggering condition based maintenance actions. So the benefits of integration, which we have seen, one is increased uptime and reliability, better product quality and consistency, reduced operational cost and energy usage, okay, and then enhance the decision making capabilities. So challenges and consideration, data quality and sensor reliability, that is very important. So whether the data which we have been obtained is having good quality, or sensor reliability, how could you able to depend on the sensor, integration with the legacy systems, cyber security and data privacy, skill gaps and organization readiness. So skill gap, because of the skill gap, the data is wrong, because in the human interruption, sometimes the data may be wrong. Okay, so that need to be carried out. Human errors they may happen. Okay, so the skill gap, the data which has been collected by the human, okay, if it is not skilled enough, obviously there may be a gap. So the skill gaps and gap in the error, what I mean, and that leads to a skill gap of the person, right? So skill gap and organization readiness. Tools and platforms which we have just now talked about are programming, MATLAB, Python is open source industrial platform. They are so even for e-test engine design, we can also do for what called Kern's method, normal calculation, or else go for a what do you call it, Aspen Plus. Even HTRA is a company-based software. Okay. Similarly, the industrial platforms like OSI Soft, PA System, Honeywell, PhD, GE Predicts, go and see and perform the see the industrial platform which has been used for this integration. Okay, of data with the process monitoring and control. And coming to future direction, self-learning control system, digital twins. Okay, H analytics of IoT integration, Okay, federal learning and collaborative AI for multi-site optimization. So coming to the digital twins, I will explain to you what is digital twins in the future direction. Okay, very important. Hope you understood what has been covered so far. So digital twins is a virtual representation of a physical object, system or process that's updated with real-time data and simulation to mirror its behavior. It's like a digital counterpart that provides insights into the performance and political issues of the physical entity. So the real-time data integration, digital twins are fed with real-time data from sensors and other sources to accurately reflect the current state of the physical object. Simulation and modeling. They utilize simulation and modeling techniques to predict performance, identify potential problems, and explore different scenarios. Lifecycle management. Digital twins can be used throughout the entire life cycle of a physical asset from design to operation and maintenance. Improved decision making. They provide valuable insights that help organization make better decisions about optimization, maintenance, and resource allocation. Various applications, digital twins can be applied to a wide range of physical objects, systems, and processes, including products, factories, infrastructure, and even cities. Example of digital twins, digital twin of a car, a digital representation of a car that monitors its performance, predicts the maintenance needs, and even allows for remote diagnostics. Digital twin of a factory, a virtual mode of factory that simulates production process, optimize workflows, and identify the bottlenecks. Digital twin of a building and a city can also be carried out. Okay, so here the benefits of using the digital twins is a predictive maintenance, optimize the resource allocation, enhance decision making, reduce cost. These are the four benefits of digital twins. One is predictive maintenance, second one is optimize the resource allocation, enhance the decision making, fourth one is reduce cost. Coming to the predictive maintenance, by monitoring the performance of physical assets in real time, digital twins can predict when maintenance is needed, reducing the downtime and cost. Optimize the resource allocation. Digital twins can provide insights into resource usage patterns, allowing for better allocation of resources and improved efficiency. Third one is the enhanced decision making. Digital twins provide valuable data and insights that help decision makers make more informed choices about investment, operation, and maintenance. Coming to the fourth, the last one, reduce cost by identifying the potential problem early on and optimizing resource allocation. Digital twins can help reduce operational costs. So, the digital twin is a visual representation of a physical object, system, or process that is updated with real-time data and the simulation to mirror its behavior. Okay, so digital twins is a future direction, edge analytics and IoT, IIoT, Internet of Things integration, and federated learning and collaborative AI for multi-site optimization. So the Internet of Things I already told you in last class also I mentioned about what I thought of implementing the Internet of Things. Okay, when I tried to do the project on biogas production. So I told you 20,000 liters of can has been used. So the biogas has been produced by dumping cow dung, and then outside the water has been kept in order to have a what is called a make the process temperature at a into the lower temperature, because the heat will be produced, right? So when you have the biogas produced, the volume is getting increased. So by using Internet of Things, we can collect the data from the through the mobile itself. Okay, so this is the advantage. The human intervention will be less, so making the human intervention is less. Okay, so edge analytics is the future direction of the thing. Federal learning and collaborative AI for multi-site optimization. Conclusion of the third subdivision of fifth unit: integration of data analytics with process monitoring and control transform the data into actionable intelligence. Okay, so by just not mere collecting of data, by collecting the data and control, transform the data into actionable intelligence. It is a key enabler of smart manufacturing, driving innovation, efficiency, and sustainability. So, hope you understood the third subdivision of the unit 3, unit 5, and the last part, that is where we are going to complete the fifth unit future trends and emerging application of data analytics in chemical engineering. Very, very important. So how, why, what for we are moving towards? Okay, application of data analytics in chemical engineering. Okay, what is the future trends and emerging applications? The introduction. As chemical engineer becomes increasingly digitized, data analytics is playing a transformative role in design, operation, and optimization. The goal is to explore upcoming trends and new applications that will shape the future of the field. Okay, so the where we are moving towards as a chemical engineer, what where we are moving to future trends and emerging application of data analytics in chemical engineering. Okay, evaluation of data analytics. So in the past, spreadsheet based data logging, basic statistical process control. Present, machine learning models like real time process monitoring, okay, and predictive maintenance. In future, autonomous system, intelligent decision making, cross domain integration. So in future, now we are in the machine learning model. In the future, how it will go actually? Evaluation of data analytics in chemical engineering, how they use the data analytics. Okay, in chemical engineering, autonomous system, intelligent decision making, and cross domain integration. So intelligent decision making. So intelligent decision making, for example, a mobile car has been moving on the road. Okay, so if there any obstacles is that, it will automatically move into certain degree and it will turn around so that it will not. It is a decision making, intelligent decision making. Okay, and a cross domain integration. So it's not only deal with chemical engineering, it will have a cross domain integration. Autonomous system. Okay, so it will automatically work on its own autonomous. Okay, so digital twins, coming to the future trends in data analytics. The digital twins I already we have discussed. Okay, so the definition goes like this: it's a real-time digital replica of physical process or equipment. Okay, underline the word real-time digital replica of physical process or equipment. Okay, application reactor performance optimization, dynamic simulation. The benefit is improved design and real-time control capabilities. Edge and fog computing. The second part, feature trends in data analytics, edge and fog computing. Definition: local data processing at the edge of the network, okay, near sensors. Okay, so the application is real-time fault detection and corrective action at the plant flow. So immediately at the spot, you just find it out and then correct it. Corrective action at the plant flow. The benefit is reduces latency, improves response time. So the third one, autonomous and process optimization, reinforcement learning. Okay, so this I already told you many times, the reinforcement learning. So could you able to recall back what is the reinforcement learning? I give you some 10 seconds to know about, just recall back what is reinforcement learning, which I told. So the reinforcement learning means, okay, it's a type of machine learning where an agent learns to make decision by interacting with an environment and receiving rewards or penalties based on his action. So the goal is to maximize the cumulative reward over time. It is a trial and error approach where the agent learns through feedback, adjusting his behavior to achieve the optimal outcomes. The key concepts are agent, environment, action, reward, policy, value action, and state. So what is the agent? The entity that interacts with the environment and make decision. Environment, the world in which the agent operates. Action, the choice made by the agent in the environment. Reward, feedback given to the agent for his action, positive or negative. Policy, the agent's strategy for selecting the action based on the current state. So the value function is a measure of how good a particular state or action is based on the expected future rewards. The state, the current condition of the environment that the agent perceives. So how it works, the agent interacts with the environment and takes an action. The environment responds to the action and transits to a new state. The agent receives a reward or penalty for his action. The agent updates his policy based on the feedback it receives. This cycle repeats with the agent gradually learning to make better decisions to maximize the cumulative rewards. Examples of applications: robotics, game playing, autonomous driving, okay, which I told you, right? Autonomous driving, and resource management recommendation systems. So the types of reinforcement learning: policy based reinforcement learning, value based reinforcement learning, model based reinforcement learning. So directly policy based reinforcement learning directly learns the policy that maps case to the action. Value based reinforcement learning learns a value function that estimates that expected reward of being in a particular state or taking a specific action. So model-based reinforcement learning learns a model of the environment to predict how the environment will respond to action. So the reinforcement learning is a type of machine learning, okay, where an agent learns to make decision by interact with the environment and receiving rewards or penalties based on his action. So that is called reinforcement learning. So the autonomous process optimization is based on the technology used in reinforcement learning, self-optimizing control. The application or continuous fine-tuning of chemical plants for efficiency and sustainability. The benefit is minimal human intervention. So all the future trends hereafter will be using a very minimal human intervention. So industry 4.0, which we also talks about the minimal human intervention, adapted to distances. So AI driven process simulation. So the future trends in data analysis is AI driven process simulation. The traditional tools which have been used are Aspen Plus and Aspen ISIS. Okay, Aspen Plus is static simulation, Aspen ISIS is dynamic simulation. Okay, future tools AI enhanced simulators for faster and more flexible design. Application real time simulation, assisted control, and troubleshooting. Coming to the advanced visualization and augmented reality. So the what is augmented reality? The people have been watching. So if you go to any shopping mall and the people have been playing with the specs. Okay, so it's an augmented reality. Is a what is mean augmented reality? Okay, so augmented reality is a technology that enhances the real world by overlaying computer generated digital elements onto it. Okay, so the virtual reality and augmented reality. So it was very famous actually some quite time for the last 1 decade. Okay, augmented reality is a technology that enhances the real world by overlaying the computer generated digital elements onto it. This overlay can include 3D models, images, video, or other information, enriching the user's perception of their surroundings. So, people will play around. The Pokemon Go, some 10 years back, it was very popular, and it was now it's not no more popular. The Pokemon Go and things like that. But even the people have been wearing the glass and watching the things in supermarket, I mean, so shopping mall and multiplex or something, right? So the augmented reality, they are working on the augmented reality. AI devices like smartphones, tablets, or smart glasses use cameras and sensors to capture the real world and then integrate digital content with the into the scene. So the key concepts: interactive experience. Augmented reality creates a dynamic and interactive experience by allowing users to interact with the digital content overlaid into the real world. Real-time integration. Digital content is integrated into the real world in real time, making it a seamless and immersive experience. Enrichment of reality. AR does not replace the real world but enhances it by adding value and information. So the various devices, augmented reality can be accessed through various devices including smartphones, tablets and smart glasses. Types of AR, augmented reality. There are different types of augmented reality including market-based and market-less augmented reality. Market-based augmented reality uses image recognition to identify the specific objects, which maker-less augmented reality uses other techniques like camera tracking and GPS. So how it works? Sensing and tracking, overlaying content, interacting with the content. Okay, so sensing and tracking. AR, augmented reality devices, uses cameras, sensors and other methods to sense and track the user's environment and their position. Overlaying content. The device then overlays digital content such as 3D models or images onto the captured image or video. Interacting with the content. User can interact with the digital content either by manipulating it or triggering the action. So when you wear the glass, the real world will be there, and about that, the digital image will come and close on it. You could be able to interact with the digital image. That's what they are saying. So the examples of augmented reality in use: mobile games, shopping and retail. Okay, apps allow users to visualize the furniture or products in their home before purchasing. Okay, so even augmented reality, before you go for construction of your house, you can wear that one and see how it looks like when you get into the thing with the map. I mean, with the sketch itself. Okay, so education, how this is helpful, augmented reality can create interactive learning environment by overlaying digital content onto the real world objects. So the different in entertainment also the augmented reality is very popular. So the difference between the virtual reality and augmented reality, AR enhances the real world while VR creates virtual reality creates a completely simulated environment. Okay, virtual reality is does not completely a simulated environment. AR enhances the real world. Okay, So AR uses a real world setting while virtual reality is entirely virtual. So that is the difference between the virtual reality and the augmented reality. Hope you understood this. So these all we are moving towards this type of trends. Okay, the future trends in data analytics that will be implemented in chemical engineering, not only in chemical engineering, in all the fields. The federated and transformed learning purpose is share learning across plants without sharing data. Application is corporate-wide models for yield prediction or fault detection. The benefit is protects data privacy while leveraging the global knowledge, federated and transfer learning. Coming to the emerging application, what are the emerging applications? Okay, so green chemistry and sustainability, analytical use, emission tracking, waste minimization, life cycle analysis. Application, sustainable process development and environmental compliance. Coming to the second part of emerging application is bioprocess and pharmaceutical manufacturing. The technique is multivariate data analytics, model based control. The application, batch process monitoring, PAT, process analytical technology integration and continuous manufacturing. So the emerging application of data analytics, okay, in future trends, maybe in the area of green chemistry and sustainability, bioprocess and pharmaceutical manufacturing, energy system and carbon management, process safety and risk management, supply chain optimization, but not limited only to this. I just give an example, some 5 examples. Okay, so the energy system and carbon manufacturing, the real-time optimization of energy usage, carbon dioxide capture efficiency prediction, analytic rules. Example, using machine learning to predict the membrane performance in carbon capture units. Coming to the process safety and risk management, the data types is alarm data, incident reports, sensor anomalies, use case predicting and preventing hazardous events through pattern recognition. Okay, so that can be carried out in the future emerging applications. These are the emerging applications. Supply chain optimization, forecasting, logistics, raw material variability analysis. The tools may be time series forecasting, digital supply, chain twins. Okay, so this can be used. What are the challenges of this future in future? Data integration, diverse sources, lab, plant, ERP, require harmonization, ethical use of AI, transparency, bias in machine learning models, cyber security, data protection in IIoT, and cloud computing. So, coming to the Internet of Things, I would like to explain about IIoT. What do you mean by IIoT? Any idea? So, Internet of Things and IIoT or the industrial internet of things. Okay, so refers to a application of internal internet connected devices and the system in industrial settings to collect, exchange and analyze data, enabling improved efficiency and productivity. It is a key component of industry 4.0, which focuses on the integration of digital technologies in manufacturing and other industrial processes. So the definition goes like this: IIoT, Internet Industrial Internet of Things, IoT, Internet of Things, Industrial Internet of Things. So I refers to the industrial Internet of Things, involves connecting industrial assets like machines, sensors, and other devices to the internet to facilitate data collection, analysis, and communication. The key elements: connected devices, sensors, actuators, PLC, programmable logic controller, SCADA, supervisory control and data acquisition. Okay, systems and other industrial equipment are connected to the network. So data collection and exchange, this device gather data about various aspects of industrial process, which is then transmitted and exchanged between different systems. So data analysis, the collected data is analyzed using various techniques, including big data, analytics, and machine learning to identify the trends, optimize the operation, and make informed decisions. So the benefits are improved efficiency and productivity by collecting and analyzing the data. Internet of Things, Industrial Internet of Things enables organization to optimize the processes, reduce the waste, and improve overall performance. Enhance safety. Industry Internet of Things can help in real-time monitoring of equipment, detecting potential issues, and preventing accidents. Predictive maintenance. By analyzing sensor data, Industry Internet of Things can predict potential equipment failures and enable preventive maintenance, reducing downtime and cost. Remote monitoring and control. Industry Internet of Things allows for remote monitoring and control of industrial process, reducing the need for on-site personnel and improving response times. So the examples and applications: predictive maintenance, optimized energy management, automated logistic and inventory management, remote monitoring and control of industrial process. So, the cyber security, data protection in industry, Internet of Things, and cloud environment. These are the challenges. Okay, in the what do you call the cyber security point of view. Okay, so interdisciplinary skill sets combine chemical engineering with computer science and statistics. Now, the people have been doing, for example, we could also could do chemical engineering in major and minor in computer engineering. So now the skill set need to be, it's not only single disciplinary is okay, it's maybe an integrate, I'm a multiple disciplinary, so you can be smart in a computer language and coding, as well as you can also have domain knowledge. Okay, in chemical engineering. Coming to the skills for the future chemical engineer: data science and machine learning programming like Python, R programming, okay, MATLAB, and things like that. So the process modeling and simulation, knowledge of control system and instrumentation, communication and interpretation of data driven insights. So the conclusion, the last part, the fifth unit, okay, this last subdivision, that is feature. Okay, so data analytics in redefining what is possible in chemical engineering. They embrace hybrid skills and new technologies to lead to the next wave of innovation in sustainable and efficient process industries. So with this note, I conclude today's section. If you have any doubt, just let me know. Otherwise, if time is needed, if time permits, I'll try to take another lecture on the recapping of Unit 5. Okay, I believe that, hope you understood what has been covered, this two subdivision. I stop it here. Thank you for your time.